So let's look at an example in 4.2 that kind of walks you through interpreting and using the line to predict. So we have a pediatrician that wants to determine the relationship between a child's height and their head circumference. And she selects 11 children from her practice and measures their heights and head circumference. So the first thing we do is follow the least square regression line. So we're going to click our icon to view the data, and then I want to open this in StatCrunch. And then we're going to go to Stat and then Regression and Simple Linear. And our X variable is, let's see what our problem says here, the height, double check here, it tells us here, and then our head circumference is Y, and then again it's easier. We're going to do fitted line plot, scroll down, and then press the control button on your keyboard, and while you're holding it down, click on residuals versus X values, and then I like to scroll back up just to make sure fitted line plot is highlighted. Under save, you're going to click residuals and predicted values. So again, you're going to hold the control button on your keyboard, and while holding it down, click on predicted values. And then we're just going to scroll down and hit compute. So our least squared regression line, I think it's easier to look here, but remember it comes on this line. This may be a little bit confusing since it doesn't have X and Y, so the third line down. Or you can look in the first table and under estimate, slope, and intercept. So remember, slope is what goes in front of X, and we went around to 3 decimal places. It's a little bit smaller here. This is so what's in front of X is our slope, and the other portion is our y-intercept here. So our slope is going to be 0.195. Be careful rounding there. And then our intercept is 12.458. Right. And then now we want to interpret our slope. So what I normally like to do is to write this out. So I'm going to pull this up here. Make it smaller. Okay, so our slope, recall, is our change in y over change in x. So in this case, it is the change in their head circumference over the change in height. Okay. And our slope is 0.195, and we can write this as a fraction simply by putting it over 1. So this is the change in circumference over height. Right? And since they're both positive, we usually put the positive for sure in the bottom, and then positive or negative up top depending on the sign of our slope, right? So every time the height increases, the head circumference increases. If this were negative, we would say for each increase in height, head circumference would decrease, right? So we're going to match our answers here. So for each increase in height, right, because you always want to start out with this, right? This is our indicator. All right, so when height goes up, our head circumference goes up. So for each increase in height, head circumference increases by 0.195. Right? And now we want to interpret our y-intercept. So I'm going to scroll back up and get my y-intercept. Right, so there's our y-intercept. Right, so there's our y-intercept, right? So as an ordered pair, our y-intercepts are always 0, comma, and then our y-intercept value Right, so our x and then y. So x is our height and y is the head circumference. So here we're talking about a height of 0 and a head circumference of 12 inches, right? So height of 0. Does it make sense? That's what we have to ask ourselves. To have a height of 0 and a head circumference of something, right? So this would say at a height of 0, we have this head circumference. But does that make sense, right? So that's the thing we always have to ask ourselves. In this case, it doesn't. So it's not appropriate to interpret the y-intercept. Right? And now we want to use our regression line to predict the head circumference of a child who is 24.5 inches tall. Right? So I'm going to use my regression line, which is y hat equals 0.195x plus 12.458. So I'm going to plug in my 24.5 for x. Right, so 0.915 times 24.5 plus 12.458. We get 17.2355. Right, it says rounded 2 decimal places. So we end up with 17.24. Right, and then we want to look at the residual. So again, our residual is the observed minus the predicted, which is y minus y hat. Right? So our observed value, when it's 24.5, we want to go back to our table. So when it's 24.5 right here is 17.1. Right, so that's our observed value. And our predicted is 17.24. Right? So it'll calculate our residual here. So 17.1 minus 17.24. And we get negative 0.14. So our residual is negative 0.14, which is negative, so it means it's below the regression line, which means it's below average, right? Right, so residual is the difference from the line, right, to the point to the line, right? And so we know this one's wrong because our regression line is not a straight line, right? And so we want to look at these, right? And so you'll notice these are all kind of close, and so let's click on these to look at it, right? And so you'll notice it's a very small scale. So if I kind of split the difference, it's about 17. You'll notice these go up 16.2, 4, 6, 8, 17, 17.2, 4, 6, 8, 18. These go up by 0.2s. Right, and then here, 24.5, 25, 25.5, 26, 27, 28. So these are going up by 0.5s. So 24.5 is here, right? And we're looking at the observed being at 17.1. And so it is 17.2, so halfway in between. And the predicted is at 17.2. So that one looks pretty good. So we're going to click here. That's on the line, so we know that that's not correct. And then here, this is significantly below, right? So we look at this. So 2, 4, 6, 8, 17, right? And this is at 1. This is 2.355, right? So this is actually above there, right? And so this is our correct graph here. So you want to pay really close attention here. So we have heights, we they're children and we get two different heights, right? So what's the difference, right? So go back to chapter 1. Remember, our data vary. Amongst ourselves, we sleep a different number of hours a night, right? So they're going to vary between different individuals, right? So one could be a boy, one could be a girl, but the difference really here is our head circumferences vary, right? And so this kind of walks you through all the different pieces of interpreting, right? And so would it be reasonable to use it to predict the head circumference of a child who's 32 inches tall? So if we go back and look at our data set, notice that it's not 32, it's between 24.75 and 28.25. You want to stay close to the model. You don't want to use the model outside of the x values that you're working with. The x values set up where you want to use the model to predict. So anything that's kind of outside of that 24.75 to 28.25 is not really good for the model. That model is based around those values. And so once you get out of that, you don't know that your model is really linear or that model is really accurate anymore. So you don't really want to use that model anymore, right? So this height is outside the scope of the model. The height that's possible is just outside of the scope of the model. Right? And so that kind of walks you through how to interpret those and kind of looking at what residuals are and how they look on the graph and then using the model, whether it's in the scope or outside of the scope. And you always want to refer back to those x values.